Thank you for joining us. This is Orbit Network Training, setting up an analog interface module, or AIM. Now, the AIM is one of several third-party sensor connection modules in which you can take a sensor and then incorporate its output into Orbit. So for the AIM, you actually have several different configurations. You have the plus minus 5 volt DC, plus minus 10 volt DC, 0 to 10 volt DC, 40 to 20 milliamp, as well as PT100, which is a special output typically for thermocouples. To get a proper configuration, you can contact your local Solartron representative. But we also have the digital input-output module, and this will connect to sensors perhaps to signal a robot, or perhaps output to a light curtain, and that's in both NPN and PNP. We have the strain gauge interface module, and this will connect to full bridge or half bridge strain gauges. You have the encoder interface module, which will connect to any sensor with a TTL output. Then you have the digimatic interface module, which can typically connect to mitotorial dial gauges that have that type of output. Now, before we get started, just a few quick technical items. First, the input frequency for the analog interface module is up to 460 Hertz. It is powered by a power supply interface module or USB interface module, like what you see there. The AIM can also power sensors that run on 5 volts of DC. That's because that's the type of power that the Orbit network itself runs on. But other sensors, perhaps ones that run on 24 volts of DC, those require outside power. Now, the next step, if you haven't already, is to, of course, go to the Solartron website and download the latest support pack. So go to Service and Support, Drivers and Software, and then Support Pack for Windows. Then you want to open the Orbit Suite. Now, before we start the software, first let's point out where in the manuals you can find this information on the AIMs. Click Manuals, Orbit 3 Module Manual. Then the information starts on page 13. See AIM Inputs and AIM Performance, and then here are the connection details for the various analog interface modules. Now, for this example, we are going to use a 4 to 20 milliamp analog interface module. And the typical setup will be like this, where you have a series of wire leads, although we can also add a plug if you so ask. And for this example, we'll also use a signal generator. So for this, you're actually going to want to connect a green wire to the current input, and then the black wire to the zero current. Next, of course, is you'll want to connect the AIM to an interface module. A USB interface module can power the AIM, no problem. If you connect it with any others, you will, of course, need a power supply. Now, to just test the AIM and its signal, you can use a software package like the Orbit Library Test. So we'll just open this, click Connect, then it's found the USB. Go to Network, and then click Ping, and Ping, of course, will find all the modules that are on the stack. So here's the serial number for the AIM, and again, this will match the serial number that you see on the back of the module. Click over here to Module, and then you'll just see all the different aspects of this device, namely the range, 4 to 20 milliamp, the probe identity, and the different module modes that it can run. So just to give it a test of this, click Start Continuous. So now, on the signal generator, I'm just going to turn. And if you'll see, it's matching the values on the signal generator. And if you just want to see it in the pure counts, because again, this is just scaled to 4 to 20 milliamps, here it goes from 0 to about 16,000. Now, one other thing you will want to do, of course, is convert that current reading or that voltage reading into a more usable number, such as for temperature, you could have it converted to degrees, or for scale, you could have it converted to weight or pounds, and that can actually be done with most software packs. So first we'll demonstrate how you could do it with Orbit GCS. So here, go to Menu, Hardware. This is already set up with the USB interface module, and do Connect. Now click Find All Modules. So here's the AIM module, and you will actually want to double click this. And then if you see, there's a user rescaling, enable, and disable. So this we want to enable. If you'll see, here's an offset, and then the multiplier. So the first thing we probably want to consider is the multiplier. So let's just suppose for a second that we are connecting to a scale that goes from like 0 to 100 grams, like the picture that you see there. And so for 0 to 100 grams, you have a range of 100, of course. And then the range of the current is 4 to 20 milliamps, so a total of 16. So the multiplier would be 100 divided by 16 milliamps, which equals 6.25. So that will enter right here. But now, of course, there's an offset because, of course, the milliamp starts at 4. For the weight, of course, that starts at 0. So here you just enter minus 4. Then units of measure, we'll enter grams. So now hit close. So then let's create that dimension just for the current module. But then we need to make sure to scale it properly. So let's go to dimensions. Just put scale. And now, right now it's set for 4 to 20. I'll just make that 0 to 100. And we'll just have a resolution of 2 there. Then click Save. Now let's press Gauge. So now if you'll see, you have the scale outputs right here on Orbit GCS. And this could run concurrently, of course, with probes or any other sensors that you intend to put on the Orbit network. So now you could also convert a voltage reading or a current reading into a scaled reading in Microsoft Excel as well. You just need to use the Excel add-in, which you can download again from the Solartron website. It's located here. But first thing you'll want to do is actually, let's just do some column headers. So here we'll have current reading, and then scaled reading. And now we'll just click connect. And then click settings. So here we have it on sheet 1. Let's have the initial cell address be A2. Have it be here. And let's just do a continuous reading in that cell by setting it up for same row, then sample on timer, and then read at flat out speed. So now we go to Orbit Networks. As you can see, the USB interface is already set up there, so click Notify Add. And then there's the AIM module. And again, you have the resolution and averaging, which you can set up here. Check this here, initial cell. Now click OK. So now if I take readings, you'll see the 4 to 20 milliamp output is in cell A2. And now we just want to do the same type of calculation we just did with Orbit GCS by just clicking equals 6.25 times A2 minus 4. Don't forget the offset. So now there is a scaled reading. Of course, if it gets up to 20 milliamps, it'll go up to 100 grams. So now here's an example of a thermocouple with the PT100 output connected to an analog interface module. Here we already have it wired to a plug. And again, since this thermocouple runs on 5 volts of power, it can actually be powered by the Orbit network through the AIM. And then just like any other sensor, you can add it to the Orbit stack. So now if we go back to the Orbit library test, click Connect, and then ping the modules again. Here is the module for the PT100. And if you'll see, the range is minus 50 to 250 degrees. And if we start continuous, it will be giving the real-time temperature in the room right now. Now here's an Orbit GCS software example where you are running the scale, thermocouple, and then 2 probes making an A plus B measurement. With Orbit, the versatility is fairly extensive.